we're going to talk about undo. What do we know about undo so far? We have discussed undo to a certain extent. Just give me one line answer. Like, what exactly is this undo?
It holds the old image.
It holds the old image of the data if we are modifying the data. So that is absolutely correct. If this is my SGA, inside SGA, the important thing is the buffer cache. Let us say this is the DBWR process, and here I have my hard disk, and on my hard disk I have the system tablespace or the data files related to system tablespace. Then this will be sysocs. Then there would be an undo tablespace. That is what we're going to talk about, and obviously temp, and maybe one more, let us say user, and then obviously control files, redo files, all that stuff is there. So when a server process gets a request from the client side, this is, let us say, SQL plus, the server process is gonna make sure that the data is already in the buffer cache. If I'm gonna run an update statement, we saw this thing last time, update let us say orders, set quantity is equal to 10, where order ID is equal to 101. So initially the quantity was 5, and now it is going to be modified to 10. So that block in which the data exists for this order 101, that block is, let us say, on the disk in one of the table spaces. The dedicated server process is going to read that block and bring it into the buffer cache if the block is already not there. So let us say the block has come to the buffer cache, and the value of that one row, the quantity is 5 originally. That has to be modified. So what Oracle is going to do, it is going to create another copy of that. Let us say we'll keep that copy here, and that 5 will come over there, and then it is going to modify this from 5 to 10. So this is the before image of that data, and this is the after image of the data. Everything is still inside the buffer cache, everything is still inside the memory, nothing has been written to the disk. When will it get written to the disk? We don't know that yet. It depends on the activity of the DBWR. Okay, so now this is undo. If DBWR thinks that the time has come to write things to the disk, even if the user has not committed that. So the main important point is user has not committed that, user is still thinking what he should do. DBWR may say that, okay, I'm going to write this block as well as this block, both of these blocks will be written to the disk. This is the original block, so it should go to the data file, which will go over here, and this is the undo block, which will go to the undo tablespace. Now, how do these things work in the undo tablespace? Let's talk about that. So I'm gonna blow up this diagram. This is my undo tablespace. Now, undo tablespace or data file related to the undo tablespace. This is like any other tablespace. What is inside that tablespace? Again, the segments, and inside the segments there are extents. Inside the extents there are blocks. So when the database is created, we create that undo tablespace, and inside that undo tablespace there are certain undo segments that are pre-created by the Oracle database. So let us say this is the first undo segment. The undo segment must have at least 2 different extents. The minimum extent requirement for undo is 2. So the first undo segment is going to have extent number 1, so extent 1, and extent 2 for the first undo segment. The second undo segment will have again the extent 1 and extent 2, and so on. There would be quite a few undo segments that will be created. So this is the first undo segment, this is the second undo segment, and third undo segment, and so on. What is the purpose of that undo segment now? Whenever a before image of a data block has to be saved somewhere, it will be saved into one of these segments. When I start a transaction, what is a transaction? Anything that starts modifying the data. Okay, select statement is not a transaction. So anything that starts a transaction, insert, update, delete, those things, what is going to happen for this specific transaction? Oracle is going to randomly, with their internal algorithm, is going to randomly allocate one undo segment. So let us say that undo segment is undo segment number 1, which is this now, is assigned to my transaction. This is done whenever we start a transaction. And then what happens, any before images that are created by that transaction, not just by this update statement, because this update statement is just going to be part of that transaction. After that, if we write a delete statement from some other table, after that we write some insert statement from a totally different table, all those inserts, update, deletes are part of that one transaction. And since undo segment number 1 is assigned to that transaction, all those before image blocks are written to that undo segment that is assigned to that transaction. So all that stuff is written by DBWR. When does DBWR write that to the undo? Whenever DBWR thinks that the time is there to write. Now, does it mean that it writes when it is committed? Does it write when the rollback happens? No, it has nothing to do with that. The moment there is not enough space here, DBWR is going to write things to the disk. It has nothing to do with the commit. So this is what undo is written. Now, what is the purpose of this undo? The purpose of undo is twofold. I will just write it down here. First purpose of undo is to allow the rollback. Is to allow the rollback, so that this user can say that I would like to roll back my transaction, I would like to get the old data from here. So what will happen, if the data is already in the buffer cache, that will be again brought back over here. If the data, if this block, when I say data, if this block is written to the disk, then this will be brought over here, and then it will be overwritten over here, and then this will go down to the hard disk. So one point to remember here, when does things get written to the disk? Whenever there is not enough space in the buffer cache. The data or any blocks, whether they are undo blocks or whether they are data blocks, they must be brought into the memory, into the buffer cache before any operation happens. So if I want to roll back and I don't have this 5 block inside the buffer cache, I will miss the dedicated server process will be bringing it from the hard disk, bringing it into the buffer cache, then writing it over here, and then later on DBWR will write it down to the disk. So again, point to remember is that data must be, the blocks must be here in order to do any kind of an operation. And why Oracle does that? Because anything that is done in the memory is actually faster. So Oracle is using that cache kind of technology, that bring it into the buffer cache, bring it into the memory, so that all the things are faster, and then whenever required you write it down to the disk, or try to keep everything inside the memory. How to increase? What is the simplest way of increasing the performance of your database? Make sure that everything is in the buffer cache. If you have large enough of buffer cache, bring everything into the buffer cache, and that is the best way to increase the performance. But obviously memory is not that easily available, and that's why we don't bring it. But whatever is required, if it is here, then the performance is going to be fast. So coming back to our undo discussion, why undo is required for rolling back? This is a very standard, well-known purpose of an undo. Second purpose of undo, I think we had also discussed this thing. What is the second purpose of undo? Flashback is there, yes. Flashback is a purpose of undo. We will talk about flashback a little later, but yes, undo is used for flashback. So I'm going to hold that discussion for the time being, and we'll discuss that undo flashback a little later. Any other purpose? It provides a read consistent image. Okay, so for providing a read consistency, now what exactly is read consistency? What is read consistency?
Readers should not pose a problem for writers, and writers should not pose a problem for the readers.
Readers should not pose the problems for writers, and writers should not pose the problems for readers. Can you elaborate a little more on that? Can you give an example?
When a user updates a row.
When a user updates a row like this, okay.
But he doesn't give commit.
When he doesn't give a commit, yes.
If he selects from the table, he will get the new.
Not if he, if somebody else.
If somebody else
selects from
he will get the old value, and if the user who updated, he will get the new value.
He will get the new value. That is what read consistency is. Read consistency is in a different word. That means nobody who is reading the data should get uncommitted data. Okay, in other words, what is read consistency? Easier to understand, because read consistency is a very theoretical word. If you really want to understand what read consistency is, it means any user who is trying to select the data should not get uncommitted data from other users. So let us say user A, this is user A who is connected to this dedicated server process. He has updated the original value of 5 to 10. This is the undo block, the undo buffer for that. So if he selects from the same table he will see 10. Okay, it is his own uncommitted data. So you can see your own uncommitted data. That is fine. That is absolutely fine. But another user B, connected to another dedicated server process, if he tries to say select star from that table, he should be able to see 5. That is what read consistency is. That is the real meaning of consistent data. Consistent data means I should not see any uncommitted transactions from other users. So that is why you said this correctly. Readers should not pose problems for writers and writers should not pose problems for reader. This is what it means. You should see only the committed data. You should not see uncommitted data by other users. So that is the best purpose of the of this whole thing. Now, where is this used? I mean, you probably have heard of one error that is very common in Oracle databases called a snapshot too old. Have you heard of that error? Any idea what that means? Snapshot too old.
Before image.
It's about a before image. Just give me a second. It is about a before image. That is correct. But any idea what that is? It is all related to undo. So let us talk about that. Snapshot too old. So let us say there is one user A and another user B. User A, user B. This is the timeline. Timeline is like 1 o'clock. Then I am just going to take a hypothetical time. 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. They are moving in time. User A has started a query. Excuse me. So a select statement has been started at 1 o'clock. And now this select statement is such a complicated select statement that it is going to take, hypothetically, let us say 3 hours. It won't take that much of time, but usually 20 minutes, 30 minutes, 50 minutes, half an hour is not a very uncommon thing. So long running reports do take time. So for our understanding, we are going to say that a select statement started at 1 o'clock is going to keep on running till 4 o'clock. So this is the snapshot too old error occurs for a long running queries, not for any short running queries. So this guy has started the query. The second guy comes in. And at 2 o'clock he updates or he deletes. He deletes certain rows from a table which is being selected by this guy. Okay. So now when he has deleted those rows, what happens to this? Immediately after that he commits it. Okay. Immediately after that he commits it. So those rows are gone. Now this guy has started doing a select. Now what is the meaning of starting select at 1 o'clock? It means I should get the data as of 1 o'clock. Read consistency. I should get the data as of 1 o'clock. And therefore, even though it is going to take me a long time to get the output, the data should be as of 1 o'clock. So simplest example, I start a select count star from table 1. Even though it takes me 4 hours to find out the count star, that count star should be as of 1 o'clock, not as of 4 o'clock when I get the results back. But in the meantime, let us say in that table there are 5,000 rows or 50,000, that is a better number. 50,000 rows. This guy is running that query. This guy comes in and he deletes like 10 rows from that table and he immediately commits it. Now when the actual result comes in, what should this user A get? What should be the answer he should get?
50,000.
50,000, and that is what read consistency is. Where is he going to get that data from? From the undo, because all these deleted data has been kept on undo. But now this is something that we all of us know, but this guy has even done a commit. When the commit is done, what happens to your undo buffer? It is actually not washed up. It is not washed out. It is just marked as expired. It is just marked as expired. The value of 5 is still there in that buffer. When it is marked as expired means what? That means it is really not required for the rollback purpose. It could be required for some other purpose, but definitely it is not required for the rollback purpose. And then what now? So even if this guy has done a commit, the data is still there, it is marked as expired, everything is fine. At this point, the user will go and say, okay, delete has happened, no problem, but I have my undo data. Why would it go and read from undo? Because this was started earlier. And this change, my query was started earlier. Some other guy came and made changes to the data blocks that I wanted at some later time. All this time difference is done by SCN. So system change number is that number which is actually going to dictate what is the time frame when the select was started, what is the time frame when the delete was started, and all that stuff, and then it would know that yes, that actually this was started earlier, and therefore I should go and read from the undo block. It will read from the undo block all those 10 rows which were deleted, and finally it will get the count at 4 o'clock, and count would be exactly accurate, 50,000. Immediately after that, if he writes a select statement, his count will be what? Same select statement. His count would be 10 rows less than this, because his query was started after the delete has happened. Okay, so different results, but they are consistent. Okay, that is what read consistency is. Now this is fine, we have understood what undo is, and this has happened because even after the delete, Oracle keeps the undo data. Now the third thing that could happen, just snapshot to old error can happen in various other ways, but I'm gonna give this example. A user C comes in and he starts his own transaction. He has nothing to do with this user or this user. He is going to delete from some very huge table. It has nothing to do with this query or this delete. Some totally different table. And for that, the undo segment that is assigned to this transaction, unfortunately, is the same undo that was assigned to B. Every transaction, this will not be assigned an undo. Select statements never get assigned an undo, because it is not a transaction, it is just a select statement. This delete will get assigned an undo segment where the 5s are kept, and this will also get assigned an undo segment where the deleted rows that this guy is going to delete from, they will be also kept. So this guy starts his delete maybe at around 2:30, or he is doing an update, and now since he is assigned the same undo, he is deleting all that row, he is deleting all those rows, and they are coming to the same undo segment. Now the undo segment becomes full. Whether this happens over here or here, first thing, those things are going to happen over here. Then undo segment becomes full. Now what is this guy going to do? He is going to say, if this has become full, there are certain expired buffers in my undo segment. There are certain expired buffers. Expired means they are not required anymore for rollback command. So this C guy, because he doesn't have any space left for storing his undo in the same segment, in the same undo segment, he is going to start overwriting on these expired undo blocks, on these expired undo buffers here. So this 5 will be now erased, and some other things will come over there. And again, I am drawing it over here, but this could happen. This could be happening on the disk as well as in the buffer cache. Okay, so this is overwritten. And now what has happened, since this expired undo block, which is not required by this, which is fine, but it was required by this guy. And since it is required by this guy, when the time has come for this long running query to go and select from that block is no more is required by this guy, and therefore user A is going to get an error message called as snapshot is too old. Snapshot is too old, this is what the meaning is, and therefore his select statement will fail because he is unable to provide a correct result. His select statement will fail because he doesn't have that undo block which he requires, and therefore after that, if we write the same select statement, it will work. I mean, this has happened with me many times. Our users have complained to me that Oracle is a very inconsistent software, and it was kind of difficult for me to understand what they were saying. They were saying things work sometimes and they don't work sometimes. And this is what they meant. Their long running report was running sometimes. Sometimes they will get an error. They will not worry about what the error was. There was some error, and they will click on the same report again. Next time it works fine. First time it did not work because some activity was going on the undo side there. So that is what the snapshot to old error is, and it is very important to understand what this is. So how do you avoid snapshot to old error now? You make sure that you increase the size of the undo table space. You increase the size of the undo table space, and therefore if there is any transaction which requires more undo, then he can grow and he doesn't have to overwrite on the previous expired image. So bigger size will make sure that snapshot to old error doesn't come in. So size or big size, big undo size, this is one remedy for this thing. But even after I have seen, this is now too cold now, and we don't have the remote, man. Anyway, so big size is gonna solve that problem temporarily. Second thing is, more than this, I have seen that even if DBA makes this in gigabytes and gigabytes, there are developers who will demand more and more undo because they want to actually delete huge amount of data. So at that time you need to force the users that instead of deleting huge amount of data and committing it, you commit partially. You delete, then commit. You delete 1,000 rows, then commit. Then you again delete 1,000 rows, commit. You delete 1,000 rows. So that is another thing that will help you. Huh?
So what will be the impact of database when you set a parameter undo underscore management equal to manual?
Undo underscore management it equal to manual. We'll come to that. We'll come to that. Give me a minute. Okay. So size has to be big. Then what did I say? Then do a frequent commits. So that is commit. Frequent commit. And then obviously there is one more thing for the snapshot to old error, which is there is an initialization parameter called as undo retention. Undo retention is equal to basically the total number of seconds. So if you specify 100 seconds there, then what it means that even after the data is committed, then keep the undo block for at least 100 seconds. Basically expired blocks are kept there for 100 seconds before some other guy starts overwriting it. So if your query is going to take 100 seconds, then undo retention parameter is equal to 100 seconds will definitely help, because other guys will not overwrite on the expired undos. But again, this is not guaranteed. There is another way to make it guaranteed. But undo retention is not guaranteed by default. So if some other transaction requires undo tablespace, then it will follow this guideline. This is just a guideline, but not a mandatory thing. So it may overwrite on that. So these are the three things that you may want to do to kind of take care of the snapshot to old error. So my whole point of this discussion was to make sure that we understand snapshot to old error. And because once we understand that, we probably will understand most of the undo activities. So this is it, and then we'll come to the next topic now, next section.